In this problem, we are given the following circuit diagram. We are also told that the phasor current, IB, is equal to 5 at angle 45 degrees amps. And we need to find the following phasor values. Well, when we first look at this, we can see that our I of A and our I of B are in parallel with each other. That means we are going to have a V of A here and V of B here, and these are going to be equal since voltages in parallel are equal. We know our I of B, and we know the resistance is this 15 ohms minus this J times 15 ohms for this capacitor. So we can find the voltage here, and this is the same voltage for A, and then we'll have this voltage over our resistance per Ohm's law, and this will give us our current. So the first thing that we're going to do is we need to find our VB. We know that VB is equal to our I of B, and this is 5 at a 45 degrees angle times our resistance, and we know that our resistance is 15 ohms minus J times 15 ohms. Now we need to multiply these two together. If we look at the notes linked below, section 9.10 extra, there's a couple of different formulas written here, and we can use them to our advantage. This is going to be multiplication of our Z1 and Z2, this being our Z1 and this being our Z2. So what we need to do is convert them to our magnitude and our degrees. This one is already in magnitude and degrees, so all we're going to do is convert this part. We know that our V magnitude is equal to the square root of our 15 squared plus the square root of our next part. This is negative 15 squared. And then our theta is equal to the tangent of negative 1 over our 15 minus 15, or over 15 minus 15. And this is going to give us approximately 21.21 for our VM, and for our theta, we're going to have negative 45 degrees. So now we can rewrite this, plugging this part into our equation here. And now we're going to multiply. For multiplication, we multiply our magnitudes together, and this is going to give us 106.05. And then we're going to add our phasor angles together. Now our angles are 45 degrees and a negative 45 degrees, so this is just going to leave us with 0 degrees. And this is our VB. However, this is not the answer. Remember, we want to find I of A. So we can plug this into our Ohm's law, say that I of A is equal to our V of A, which is equal to our V of B, so we'll just write V of B over the resistance at A. For our resistance at this part right here, this is our I of A, we have our 25 ohm resistor and our J 25 ohms for the inductor. So this is going to be our setup, and we can just plug our V of B into here. Now to solve this, we want our magnitude and degrees. So we are going to have to change the bottom part to be in magnitude and degrees. We're going to do the same thing with our Vmax and our theta. And that's going to give us these two values right here. So now we can rewrite our equation. And after we do this, we are going to take our first part and divide it, and then take this next part and subtract it, subtracting the bottom from the top. And this is equal to the magnitude of 3 with the angle negative 45 degrees. Now we're going to solve for our I of C. For our I of C, we're going to use node voltage analysis, and we're going to look at this node specifically. We know that our I of C is going into this node. So if a current's going into a node, it's a negative. We'll have negative I of C. We have our I of A, which is going out of our node, so we're going to have a plus I of A. We know that we have our I of B also going out of our node, so we're going to have a plus I of B. But at this node, it's going to be the same. So whatever current is coming through this way, it's going to split for I of B and this current right here. However, we know that this current is actually flowing in to our node. So it's going to be a negative 2 with the 45 degrees, and this is equal to 0. And I'm going to rewrite some stuff and plug things in. From here, we need to convert this from our magnitude and theta to our Vmax and our imaginary number. We're going to do this with each of them. To start this off, we are going to have our magnitude outside, and then we're going to have the cosine with our angle inside of it, negative 45 degrees, plus J times the sine of our angle, which is 45 degrees, and this is all in brackets. We're then going to repeat this process for this part and this part, obviously using different values. From here, we can add these together and factor in our VMs out front. If we add our 2.12, 3.5, and subtract our 1.4, you're going to get that our IC is equal to 4.22, And now we're going to add our j's together. So we have a negative 2.12 plus our 3.5 minus our 1.4. And this is going to give us approximately 0. There are some rounding errors here, so this should be 0. However, if you add all of these specifically, it's not going to give us 0. But again, that's because of rounding errors. So we're just going to add a j times 0 here. If you didn't round everything down like I did, then you'll probably get exactly 0. However, if I add all the numbers I actually got out of my calculator, it turns out to be 0. So from here, we have our IC. We just need to convert it back into the phasor form, I think it's called, where we have the magnitude and our angle. To convert it back to our phasor form, we're going to have the square root over our first part squared plus our second part, which is the imaginary number, squared. If we do that, we're just going to get 4.22 as well. And if we get our angle, we know that we have a theta is equal to tangent of -1, and then we have our imaginary number over our real number. Well, our imaginary number is 0. And since our imaginary number is 0, it's basically going to be tangent -1 of 0. And we know tangent -1 of 0 is equal to 0. So our answer here is going to be 4.22 and 0 degrees. Now we have to solve for our VG. We have our VG here, we have a VA here, and we have a resistor here. So we can calculate the current going over this resistor with our IC. We're going to have our VG minus the VA. This is happening over our 5 ohm resistor. It's right here. And this is going to be the current equal to our IC. From here, we're going to move some things around and plug some things in. We know we want to solve for our V of G, so that's going to be by itself. We're going to set this equal to our 5 times our I of C. And we know our I of C to be 4.22 with an angle of 0 degrees. And we're going to add to this our V of A. And if we scroll up here, we can actually see that we've solved our V of A previously. It says VB right here, but we know that VB is equal to V of A. So we can just copy this and bring it down to our current equation. Once we have this in, we can go about solving this problem. So we want it with our Vmax and our imaginary number. To do this, we are going to take this and take our real number, which is 4.22, and then multiply it by our cosine with the angle inside of it, plus our j times the sine of our angle inside of it. If we do this, we are going to get 4.22 plus 0j. So our imaginary number is j. And for the second part, if we take it and plug it in just like this, we are going to get the first number, 106.05, plus a 0j. Now we're going to plug this back into our formula, so we have VG is equal to 5 times this first part. So we're going to have 5 times our 4.22, and this is going to give us approximately 21.1. And then we're going to multiply our 5 into our 0, so we're just going to have plus j, and it's still 0. Now we have our next part, this 106.05, so we're going to plug this in here, and there's nothing being multiplied, so it's just how it is. If we add these two together, we're going to get that our V of G is approximately 127.15 plus a 0j. And now we can convert this back. We know that our V magnitude is equal to the square root of our first number plus the square root of our second number. This means that for this problem, we're going to have 127.15. And we know that our theta is equal to tangent of -1 over our imaginary number, which is 0, over our real number, and this is going to give us 0, and tangent -1 of 0 is just 0. So for this, our V magnitude is 127.15, and our angle is going to be 0 degrees. And that is how you would go about solving this problem. If you want more introduction to circuit analysis, there's a playlist as well as notes that cover this entire coursework below the like button in the description. And if you have any questions about the material, you can leave them in the comments below.